I'd like to introduce everyone on the team here. So for those who are watching, we have a bunch of great folks from Califront, Bruno and Bill Feitner. Nick Shaw is joining us, and Nick has been involved in the NBC LUT work that is now starting to get out to the public and has been introduced with our recent FS-HDR firmware update as well. And then Bob, Tim, and myself from AJA Video Systems. So I'm just going to sort of play a little bit of the MC here as we go through. And we're going to talk through a few little topics today. One of them is going to be single master workflows. We're also going to talk about LUTs and why there's so many different types of LUTs and what does it all mean, especially as once again with our latest firmware, we've introduced more options for you as a user so that you can apply the right things to the right types of projects is really key. And we'll take a look at a little bit of that. Also, one of the interesting things we've done with FS-HDR recently is we've introduced the ability to control delay timings a little bit more. And we'll talk a little bit about what that means and why. And then we'll end it off on our side from the point of view of just having a little fun of reminding ourselves what this human visual system is all about that we're trying to really serve here when it comes to HDR techniques and workflows. And then we look forward to your questions, of course, so that we can pass it around the team. So when it comes to the initial workflows that were out there, it could be a pretty expensive operation because, of course, SDR workflows are still the majority of workflows as consumed by people today. But of course, you want to be able to move that HDR material through. And effectively, as you can see through here, you're landing up with a fair amount of crosstalk, so to speak, as well as almost two separate pipelines. And that's not really advantageous when it comes to both the financial or logistical headaches of taking stuff to air, right? So a modern single master HDR workflow took a lot of thought and a lot of work between all of us here on the panel to ensure that we could sort of combine it and make clear in terms of all the logistics, especially, bring it down a bit because it's not going to be attractive to introduce a new workflow that requires too much extra equipment, nor is it particularly practical in a lot of environments. So on that front, I'm going to pop now into checking in with our panel here. And I think, Tim, let's get your perspective on why it was important, and I'm just going to pop off the screen here for a second, to address the single master workflow. And effectively, how did you achieve this?
Well, single master workflow, I think, is just kind of born out of necessity, right? For all the reasons that you just shared, try to reduce the amount of equipment that's needed, the amount of people that's needed, the amount of everything that's needed to try to run a dual stream workflow to achieve an HDR and SDR program output. And so born out of necessity, the idea to convert everything into a single common production format for the production switcher to be able to manage was something that quickly became a necessity and is evolved. And it's been well used today to basically convert non-HDR signals into a single common production format where everything can then be mixed together in the production switcher. And then at the output, you convert it into your other various deliverables that are needed for your HDR program, your SDR program, and the different variants of each.
So a product like FS-HDR, it sounds like you're effectively are capable of putting out both the HDR process or transform signal at exactly the same time as SDR. Is that correct?
Well, yeah, and we haven't really spoken a whole lot about product specifics that can help achieve this goal. And you mentioned the FS-HDR, and for those that aren't aware, the FS-HDR is a frame synchronizer that AJ offers that has two different modes of operation. One is a 4-channel mode where it can process 4 HD channels at one time, or it can operate in UHD mode where it can process a single channel of UHD at one time. And by processing, it can do a lot of different things. It can be an up-down cross converter, or it can be an HDR transform device. And when you're in 4-channel mode, that means you can convert 4 different channels from SDR to HDR or any combination thereof. In single channel mode, you got 1 channel of the HDR transforms. And we've got several different modes or tools that we offer within this product to help our customers achieve that, because not everybody has the same idea about what their look is, what they want their look to be, how they want it to perform. So we offer several different modes of operation. The first one being the color front engine, which I'll leave to the guys at Color Front here to talk about. And we've also got 2 other modes with the BBC HLG LUTs, which I spoke about in my earlier presentation, as well as the new NBCU LUTs. And this is just a picture here or a couple pictures of the FSHDRs being used in application and deployed. This here is a different topic, but something I think we also want to get into, right, Bryce?
Yeah, so let's talk about this a little bit, and I'm going to throw it out here in terms of your view in terms of the broadcast space, and then we'll ask Bruno a little bit about how this might be applicable in narrative workflows and so on. So within the version 4.1 firmware, and by the way, when it comes to the FSHDR, you can always download this firmware for free off the website and to get these latest features. One of the key items is this increased buffer depth. So Tim has put together a nice little animation here.
Yeah, and I can walk through it. The bottom line here is we're seeing a lot of changes in production workflows today. They've been kind of happening. COVID accelerated some of them, where people are using more and more augmented reality in their live productions. And as such, those augmented reality sources have a much larger processing time associated with them. And if you're going to do your live production right, and you're going to cut between sources and have it be seamless and not have multiple frames of difference between 2 sources, you need to have a frame sync that can buffer those other sources enough to be able to be output in time with the AR source. And until this latest release of firmware, the FSHDR only had up to 6 frames of configurable delay. And through the brilliance of the engineering team and their capabilities and the hardware that we had, this latest firmware release allows you to now have up to 20 frames of configurable delay, giving you more than ample amount of control over the frame synchronizer to keep all your sources in time. So we deployed this. Customers are extremely happy. Before they're putting sometimes 2 boxes in series just to achieve as much delay as they needed, and now they can get back to using a single box and these AR sources.
So Bruno, along a similar route, because Color Front's got a very long, deep history within the narrative space. Starting out. Especially features, episodics, and that type of thing. And as we talked about the other day, there seems to be a growing need there where perhaps on many projects, you're actually yanking green screens out of the scenario. We are familiar with The Mandalorian and items like that. And therefore, you land up utilizing even game engines like Unreal Engine to sort of drive the displays. Could you talk to that a little bit in terms of how this
we're some of our business with the FSHDR and Color Front is doing The Mandalorians or other shows that have LED screens where you no longer shoot, like you said, in front of a green screen. You shoot in front of LED screens, and you have cameras tracking people tracking in front of the screen, so actors can actually be in front of a spaceship or in front of a planet or in front of a desert type of scene. So several shows have had that, and obviously with AR or with LED screens that looks like natural green screen powered by game engine, the delay is bigger. So the ability to have cameras, sound device, and everybody to be at the same timing, and which is obviously more than 6 frames, but 20 frames or even more sometimes, is paramount to be not only in the broadcast world, but into the episodics and / movie business that we use FSHDR with, using the Color Front engine or any other engines on the FSHDR. it's one of those, there's only time that slower is better, right? So usually faster is better. And this, you need to slow it down because, you know, other things are in line for having everybody in sync.
Yeah, I think that's the fun thing with all these technological challenges we all face. One minute you're diving head first to get rid of that latency, and the next moment you're going, well, hang on a second.
Yeah.
You also need to go the other direction, simply to deal with real world pipeline, you know, issues. So I think what would be good to do at this point is let's see about the core of what this is all about, which is color and luminance transformations, right? And I'd like to go to Bill here for a minute before we speak to Nick with some of the newer stuff. The partnership that was developed here working with Colorfront, you know, serves a lot of purposes. And I think one of the great things Colorfront's always brought to the table and to the industry in general is there's been a great emphasis on artistic intention. So there is, as I've always tried to describe to people who sometimes get confused about it, there's a certain amount of things you do that need to just technologically be aligned, and that might meet some math that keeps people happy and, you know, engineers who are panicking out in the field for a live sports thing or something. But then there's also the reality of really trying to get the most of what HDR is really about. So could you address that a little bit, Bill, so that we, you know, we can give folks an idea of what's really going on?
Yes. Yeah. So you're going to bring up, let's see, you got the slide up now? Yes. Okay, cool. So, you know, we're talking about having to serve multiple masters. We don't want to do, as Bryce showed, multiple shows in the, you know, multiple color paths for every single master or for every single source. So the basic philosophy is to take all the divergent sources, and in this case for broadcasts, we can usually categorize it as either as traditional SDR or HDR, and put these into a common color working space, which can then go through the Vision Mixer, and you do all the normal stuff you do there, and then output, and then transform to the deliverables and the output. So there are a number of ways that people have done that, from LUTs to you know, different flavor LUTs, et cetera, et cetera. What we bring to the table and what we tried to do is go back to that first slide. I think that'll be interesting. I'll just finish up that one a little bit. Yeah. So it's just basically, well, what happens to the human, you know, taking the human visual system into account when you do these transforms. In other words, we want things to look the same within the available display gamut or display range that we have. So that's the whole idea about this perceptual engine that we have, where we do the transforms within a perceptual space that has a perceptual model of how our human vision system works. So go to the next slide then. So here's a use case that we have an SDR source, and we want to, you know, convert it into HDR. Okay, so there's a number of ways to do that. You can just place the original SDR image right inside the HDR container, and then when you look at the TV, it's going to look the same. I mean, it's a, you know, you could have two displays, one in the original SDR and one with the SDR shifted into it. And there's one inherent problem in doing that is that it's probably being bookended with brighter images and things. And most people with HDR want to see things a little bit brighter. So there is one technique that's done quite often, and that is just place the SDR image inside of the HDR image at twice the brightness, or roughly 2.03 times the brightness. And, you know, still just a bright SDR picture, not really taking advantage and really aesthetically matching the bookended original HDR material. The other thing is just to use a simple curve, and then let's just tweak the highlights up a little bit and do that. And yeah, you can get some brighter highlights and peak the highlights, but none of this behaves properly as the way we will see it. In other words, if we're looking at an original SDR picture, we want to just see an HDR equivalent, as if that picture actually were image originally in the HDR. So using the number one thing on here, where we have the, maintain the perceived colors and the tonal relationship, then that's what we really want to do. And what we do is quite simple, is we'll unbuild the SDR picture, go back to as close as we can to seeing linear, and then we use our perceptual engine to map that linear image into the destination dynamic range and color palette. And now things look the same, and we actually have something that comes very close to if we had the original HDR picture. So let's go to the second slide. I can't show you that on here. I have some demo slides because we're only looking at SDR. So here's the opposite direction. We have HDR source, and we want to, okay, put this, convert this down to SDR. Well, there's a real problem. I mean, some people say, well, let's just clip the HDR image, at 100 nits and fit that inside the SDR container. Well, it works up until you hit 100 nits, and it looks real ugly, and you're missing all that bright material. The other thing is, well, let's do the opposite of what we talked about. Let's reduce the brightness in half and then put it inside of the SDR container. Well, that really alters the look of it, and still we will have a lot of things in that HDR picture going well above the 203 nits, and they just get clipped off. And we could use a curve once again to try to knee it down a little bit there. And if we knee it down, well, okay, we'll start getting some more highlights, but they don't belong with the picture. None of this belongs with the picture because it hasn't been done with the intent of maintaining the tonal relationship and the perceived colors of the original source. And that's why using the perceptual remap, then this happens, and it does the same technique. Unbuild the HDR image back to seeing linear, use the perceptual processing engine to map it down into the smaller color space, as well as primaries, because we've got to remember we're starting with these wider primaries, and if we simply just clip the colors, we come up with a lot of errors and disastrous results. I have on the next slide an extreme case of this. This is, and you have to be extreme on PowerPoint things, so I for it to really show up. So this is just taking an HDR image, mapping it down to half the brightness, and then clipping off above that, and then putting it out as SDR. And you can see what happens. There's a lot of hue shifting going on. Look at the blue things at the bottom, the hard clipping looks really ugly and everything. Now, if we put it through the proper perceptual remap technique, go to the next slide, you can see, okay, everything holds back in. We've held all those original colors. Yes, they are, if we had the original HDR picture, we'd find, oh, it's not as dynamic and punchy, but the basic tonal relationships to how we see it will remain the same. Let's go to the next slide. Here's a real world picture. So this is doing the same thing. It's just hard clipping past 203 nits and not really preserving the aesthetic intent of the original HDR picture. And you can just see, look at the colors and things are just punch out. There's no color in bright areas and everything. And go to the next one. This one's mislabeled, but this is going through the perceptual engine. And you can see now, look at the girl on the left in her white blouse. You see now we got color and detail in that. And the faces all look good and everything. Go back, just step back one. And you can go back one slide. Yeah, you can see how that's just blown out and there's no color. Look how dark the greens are, and just the contrast doesn't match. Now we go to the next one. And this really will match the contrast of the original HDR image. I only wish we could have HDR image monitor right next to this so we could show that, but you have to take my word for it. So that's the real reason of doing this more sophisticated mapping, so that things fit together and we've maintained the creative intent in broadcast. I think people haven't too often seen that and are quite amazed at how well this works. When we're in the other side of the industry, which is the effects side of the industry and the dramatic side of the industry, this really is apparent and very, very important. So go ahead, and I think you had some slides, Bryce, just to show some of the color tricks, just to bring home the concept that our eyes, even though it may look good on the scope, or even though empirically you measure, oh, this is twice the brightness, I have twice the photons coming out, it doesn't necessarily look twice as bright. And I think you have some tricks to.
Yeah, we'll take a look at that in a sec here. So I want to build on from where you've gone essentially with PQ, right, and perceptual quantization. when we brought out the FS-HDR, it was initially a single color front engine with some BBC LUTs. And so for those that are working with the box there, you've got quite a wide range of version 1.5 BBC LUTs that are joined now. We also introduced the ability some time ago to bring in your own LUTs, 33-point LUTs as well. That's important, as Bruno knows fully from narrative work. There's often a colorist or someone in the background who's got his own concept of how things should be for this particular project. But Nick, in terms of your work here for NBC Universal, we've just been able to include some LUTs here that are really fresh to the market. What was the brief that you were given in terms of the challenges that you were trying to address by getting these LUTs into the market? And I believe this is particularly within the live space, correct?
Yeah, the LUTs that we made, the NBC Universal LUTs made with the Orion Convert algorithm, were made specifically for use in live sports. So NBC Sports had very particular ideas in mind of what they wanted, and there is no one right answer. And if you have a LUT is a black box. A LUT takes values in and produces values out, and the processing that LUT does is obviously mathematically calculated with an algorithm, but then that maths disappears, and all you're left with is the black box that is a list of inputs and a list of outputs that correspond to them. And so Chris at NBC felt that the available LUTs were not doing what he wanted, his very specific ideas about holding the signal up to actually a pretty high level as an absolute correspondence between the HDR and the SDR, and then compression in the highlights. And so the Orion Convert algorithm, we basically developed this algorithm which has a simple set of controls, but a simple, powerful set of controls that lets the user tweak the way the conversion is done. So we gave NBC an implementation of the algorithm live with controls, which, I mean, as Bill was talking about earlier, an algorithmic conversion is the ideal, where you are making some choices about how the conversion should be done. So in order to create these LUTs, we gave Chris a live implementation of the algorithm that enabled him to choose the thresholds at which compression came in, how exactly the threshold of the compression was applied, and this unique two-stage process which our algorithm has. And then once he found the parameters which did what he wanted, then he was able to give us back those parameters, and we could bake those down into LUTs, so that an algorithm obviously requires a specific piece of hardware and currently no hardware exists that can implement our algorithm live, but it can be applied to a still image in our processing. And then once you find what you want, you make a LUT, and LUTs are easily and freely distributable and can be then applied in a range of different hardware, so long as and software indeed, as long as the LUTs are made in the correct form for that. And there are complexities that different hardware and software applies LUTs slightly differently in terms of ranges and so forth. But as long as you're aware of this, you distribute the right LUTs for the right systems, and then the algorithm can be quite well applied with chosen parameters in whatever hardware the user has.
That makes sense. So, our pleasure to have been able to include that in the latest set of firmware. And I think the key thing there for any viewers, and it's great that this meeting is recorded and will be available to many others post today's webinar. I think where we land up with is you got a lot of choice, and you're going to be able to choose dynamic LUTs when you're working with other pieces of software alongside an FS-HDR. You have the option here now to work with these NBC LUTs. which again can tie into some of, folks will be using those LUTs and software and the rest of it. And much the same with ColorFront in terms of transcoder and the similar engine that's going on through this. So it's really about picking and choosing your workflow and understanding where you need to land up. I think that's the key thing when I speak to a lot of people, especially editors in the early stages. They're a little too terrified and they really don't need to be. It's the way it's always been. Start with the end in mind and work backwards from there and assemble your pipeline with all the right pieces of kit to get there. So I know we're running out of time here, but I just wanted to sort of end this off with a little bit and return to our presentation here. And just all of this again is about trying to get technical means to help explain creative intent. And the bottom line is it's an interaction between the cones literally in your eyes and what the brain does with it from there. So like Tim, for instance, I think if you'd like to, just comment a little bit on what right now is making me feel ever so slightly stunned. You're on mute, sir.
We're out of time, but the bottom line is these are just a couple of images that are optical illusions, if you will, that kind of play with your brain. This is a still image, but yet when you look at it, it looks like it's actually moving. The previous one also a wide array of colors that also look like it's kind of moving, and there's some other ones here that the next one, which also kind of plays with your brain. You look at the A and B blocks, and our brain tells us that they're different colors, but if you actually put this like was done here, they have the same RGB code values of the A and B blocks, 120, 120, 120. So it's our brain that's playing some of these tricks on it. It's what some of these algorithms like ColorFront engine take into play as it's doing some of its transforms. And I'm sure what other people that are generating their LUTs also try to consider as they're developing some of their looks. But anyway, yeah, thank you. And we'll let you guys get back to the conference. Appreciate you attending the roundtable.
And thank you everyone on the panel for joining us today. This was great fun.
Pleasure.
Pleasure.
Thank you.
Thanks, guys.
All right.